Hello everyone, so you should be on page 20, or sorry, 19, should be on page 19 in your notes. This is U2D4, sine, cosine, and tangent ratio 2. So continuing on what we did yesterday, we're going to work on using the sine, the cos, and the tan ratios to calculate unknown sides. So the first thing we're going to have to do is write the three primary trig ratios for each of the following. So what we talked about the other day was the three primary trig ratios are sine, cos, and tan. So they're on the back on the chart paper, and we're going to write a ratio for each one. So for the first one, it doesn't say show where the theta is, so I'm going to put theta right there. So that's our reference. We know that the 10.4, because it's across from the right angle, the 10.4 will be the hypotenuse. The 8.6 is adjacent to the theta, or beside the theta, so that's the adjacent. And on the opposite side of the triangle is the 5.8, and that's the opposite side. So then to write the three trig ratios, I'm going to have sine theta equals, and sine is opposite over hypotenuse from the chart, so you would have 5.8 over 10.4, and that's the ratio. We do the same thing for cos. So cos theta off the chart is adjacent over hypotenuse, so adjacent is 8.6, hypotenuse is 10.4, so we're going to have 8.6 over 10.4. And then the last one is tan, and tan is opposite over adjacent, so it would be 5.8 over 8.6. And those are our three ratios. So for the next one for B, let's put the theta here, and we'll do the same thing. So we start off by labeling the hypotenuse first, always the hypotenuse first. So the hypotenuse is across from the right angle, so this is the hypotenuse, where the 13 is. Beside the theta is the adjacent, or adjacent to the theta, so this is adjacent. The 12 is adjacent, and the 5 would be on the opposite side of the triangle, so that's the opposite. And we're always looking at the theta when we're figuring which one's the opposite and which one's the adjacent. So we do the same thing. So we need sine theta, cos theta, and tan theta. So just by looking at the chart on the back, sine theta is opposite over hypotenuse, so it would be 5 over 13. Cos is adjacent over hypotenuse, so it would be 12 over 13. And tan would be opposite over adjacent. So 5 is the opposite, 12 is the adjacent, so it would be 5 over 12. And that's part B done. Same thing for part C, so we'll put the theta here. You would be given the theta. I didn't put it in the diagram, I'm not sure why. So same thing here. This is the right angle. Across from the right angle is the hypotenuse.
Jamie Archer, please come to the receiving room. Jamie Archer.
Announcement in the middle. Beside or adjacent to the theta is adjacent, so 24 is adjacent, so that's adjacent. So make sure you're writing this down on your note. When you're labeling the sides is very important, otherwise people make mistakes. And on the opposite side of the triangle from the theta is opposite. So sine theta would be equal to opposite over hypotenuse, so it would be 29 over 38. Cos theta is adjacent over hypotenuse. Again, these just come off the chart at the back. So turn around and look. 24 over 38. And then the last one would be tan theta, which would be opposite over adjacent. So 29 over 24. Okay, if I was marking this, these would be out of probably 3 each. 1, 2, 3, 1, 2, 3, 1, 2, 3. So you can expect a question like that on your test, and it would be out of 3. For the next part, for number 2, it says determine the value of each to 4 decimal places. So we're going to round off after 4 decimal places. So all you're doing is using your calculator here. So to work out the sine of 42 on your calculator, I'll get my calculator here. So on mine, I press sine. Let's see what I'm typing here. So sine and then 42. You might have to hit 42 first, depending on your calculator. So if I punch that in, sine 42, I get 0.6691. So I'm looking to round off after 4 decimal places. So after the 1 is a 3. The 3 doesn't tell the 1 to round up, so we're just going to leave it as a 1. So it's going to be 0.6691. And then you do the same thing with tan for the next one. So tan 14. Flip this around a little bit better. So tan 14. So I press tan and then 14, which is 0.2493. After the 3 is a 2, which tells the 3 not to round up. So I just leave it like that. The next one is cos 3, so I press cos 3, and I get 0.9986. After the 6 is a 2, so we leave the 6 at a 6. Next, number 3. So now we're working backwards. So it says determine the measure of each unknown angle theta. So we don't know the theta, so it's backwards from this one here. So on your calculator, above the sine button, you should see, move this so you can see it. So above the sine button, you've got sine to the power of -1 here. So that is the inverse of sine. So to do the opposite of sine, I'm going to press second function, sine, and then I put in that decimal, 0.4067. And does it say to the nearest angle degree? It doesn't. So we'll just round it off to the whole degree. So 23.997, if I look after the 3, the 9 tells it to go to a 4, so I would have theta is 24 degrees. It equals 24 degrees. For the next one, same idea. So you press second function cos 0.9821. That works out to 10.8 degrees. The 8 tells the 10 to round up, so it would be 11 degrees. So theta is equal to 11 degrees. And then the last one, slide my page over. I have tan, so I'm going to press second function tan. 4.3218, and I get theta equals 77 degrees because the 9 tells the 6 to round up. Okay, so pause it, rewind it where you need to. That's that. That's the calculator work. Number 4. Find the length of the unknown side to the nearest tenth. So I need to make sure I round off to the nearest tenth, which is 1 decimal place. So the first thing you do with these triangles is label them. So across from the right angle, that is the hypotenuse. So here's the hypotenuse. Now we don't have a theta here, we have an angle. So 21 degrees is like the theta. So I'm going to reference the adjacent and the opposite based on that. So beside the 21 or adjacent to the 21 is x, so that's adjacent. And then on the opposite side of the triangle from the 21 is the opposite side, so that's the opposite. So you look at the back of the chart and you decide which one you need. So I need something with adjacent and hypotenuse. I don't care about the opposite. So if you look at the chart at the back, you should be able to see that you need cos. So I would write the formula first. So that's going to be a mark. Cos theta equals adjacent over hypotenuse. And then I can substitute things in. So 21 degrees is going to work that theta is. So I'm going to cos 21 degrees equals, the adjacent is x, and the hypotenuse is 12. So it's going to be x over 12 feet. Then you work out what cos 21 is on your calculator. So on your calculator, you would type in cos 21, and you get 0.93. So I'm going to have 0.93 equals x over 12. I need to make this into a fraction, so I put it over 1. And then we're going to cross multiply. So 1 times x is x. 12 times 0.93 is 11.16. But I need to the nearest tenth, which is 1 decimal place, so you can't see that. So 11.16 would, looking after the 1, the 6 tells the 1 to round up, so it would be 11.2, and that would be 11.2 feet. So that's how you do that one. Next, same idea. I'm going to do the next one. I'm going to label first. So you always have to label them. Make sure you label them. It'll be worth the mark. So this is the hypotenuse. 58 degrees is where the theta is. The theta, that's the angle. So beside the 58 or adjacent to it is the adjacent. So the x is the adjacent. On the opposite side of the triangle is the opposite side. So then I need something that I want the adjacent, and I have the opposite. I need something that has the adjacent and the opposite. So if you look on the chart at the back, it's tan. So tan theta is opposite over adjacent. That's supposed to be a J. So I replace the theta with 58. So I'm going to have tan 58 degrees equals, the opposite is 29. The adjacent is x. Then you punch this into your calculator, and you get tan, where am I, tan, let's see what I'm typing, tan 58. 1.6. 1.60, so I'll put 1.60 is 29 over x. I need to make the 1.60 into a fraction, so it's going to be over 1. I'm going to cross multiply, so I'm going to have x times 1.60, so 1.60x equals 1 times 29 is 29. And then I have to divide by the number in front of x, so I divide by 1.60. So these guys will divide each other out, and that's going to give me x equals 29 divided by 1.60, 18.1 meters. Safety box that guy. Safety box this guy over here too. Okay, so 18.1 meters. So if I was going to mark this, this would be out of 1 mark for labeling the sides, 1 mark for choosing tan, 1 mark for substituting improperly, 1 mark for working out the 1.60, probably 1 mark for the cross multiplying, and a mark for the dividing. So that's out of 6. So probably 5 or 6 for all of these. Last one. So we have to go with the label them. Across from the right angle is the hypotenuse. The theta is the 52 degrees, so beside the theta, or adjacent to it, is the adjacent. And the opposite side is the opposite. So you look at what you need. I want the hypotenuse, I know the opposite, I don't care about the adjacent, so that is sine. So I'm going to have sine theta equals opposite over hypotenuse. So replace the theta with 52, so sine 52. The opposite is 8.6. Hypotenuse is x. Now I can work out sine 52, so I type in sine 52, and I get 0.79. So make sure you get that on your calculator. I have 8.6 over x. Put this over 1, so they're both fractions, and then I can cross multiply. So x times 0.79 is 0.79x. 1 times 8.6 is 8.6. And then what I need to do is divide by the number in front of x, so divide by 0.79, divide by 0.79, and I'll get x equals 8.6 divided by 0.79, 10.9. And that would be centimeters. Safety box that guy. And I just noticed I didn't put in the units here, so I should put in the units. It should be 8.6 centimeters and 52 degrees. Okay. Oh, you can't see my answer. Oh, there we go. Sorry. 10.9 centimeters. Okay, pause it, rewind it where you need to. Good luck with this. So you should be working on, from the textbook, page 254, number 1, 3, 5, 9, and 11. So the textbooks are at the front of the page, or at the front of the room on the shelf. Good luck.